One of the things that I notice about soybean discussions in general is that they focus a lot on row spacing, variety selection, herbicide management, insect management. I don't often hear a lot about fertility management. And I don't hear a lot about fertility management when I talk to our researchers either. This is a bit of a thing with soybeans. And if I were to ask, how many of you think that the soybean nutritional needs are different than corn or wheat nutritional needs? I don't know that our heads are there. I don't know that we have all the answers on that. And so when I'm asked a question like this is kind of the interesting question that was given to me was, what's it going to take to grow 100 bushel soybeans from the fertility side? And I thought, well, I talked to some of my colleagues, and they were all kind of in agreement, is I think we're going to have to probably shift our focus to soybean nutrition. It's a different crop. It's different than the grasses. And I think when we look at, we typically think fertility when we think corn, and we think fertility when we think wheat, because those require nitrogen. And when we think about nitrogen in the program, then we get to thinking about phosphorus and potassium and micronutrients possibly, sulfur. But the nitrogen is the thing that initiates the discussion. Then you got soybeans. Well, they fix nitrogen. We don't need to apply nitrogen to soybeans, so the fertility discussion gets dropped on soybeans. And we've got the fertility out there for the corn or for the wheat, and the soybeans can just kind of ride on what we've got out there. And I want us to think, if we're going to grow 100 bushel soybeans, if that's where we're going, then we need to think about the soybean crop in particular. What are its unique nutritional needs? And so that's kind of where I want to go with this talk a little bit. Part of this is, we know some things, and part of it is just kind of going on your creativity. Greg Carlson's going to follow me talking about on-farm research. And it's a well-timed discussion right after this one, because we don't know everything we need to know about fertility on soybeans. So this is a great opportunity for you to maybe try a few things, and that's what I'm going to do, is to put a bug in your ear on a couple of things. You can try them. You'll come up with a lot more creative things than I can give you here. This is just to kind of start a long discussion. And I think that's where we're going to be going with soybean fertility, is this is the start of a dialogue that we'll be having for many years, like we've had for corn and for wheat and the other crops that we grow. So the very first thing about 100 bushel beans is just thinking about, what are we removing with 100 bushel beans? And it's a lot different. And what I'd like to talk to you a little bit about is a nutrient budget. This is something that's just like any other budget that you keep on whether it's money or whatever it might be. An energy budget, if you're dieting, calorie counting, it's all about budgets. And the nutrients are no different. When we're looking at nutrient budgets, we're basically looking at, what are we applying? That can be as fertilizers or manure, but those are the things that you want to keep good records on. All of the nutrients that go down. Then we have the uptake of those nutrients by the crop, and it takes up more nutrients than you take off with harvest. But we have to know how many of those nutrients are harvested, what quantity of each nutrient is harvested, and then we compare the two. We look at how much we applied total with how much we removed. And we consider whatever time period is really meaningful for us. Usually since the last fertilizer or manure application up until the next one, just take a look at how many crops you've grown since those applications, and then do some estimates of crop removal. Now if you take a look, there are published estimates on the amount of nutrients per bushel that are removed by each of the crops that you grow. And I want to challenge those a little bit. And I'll talk first about something that we've done on looking at nutrient budgets, just comparing how much is applied versus how much is removed. We've done this at a very large scale. We have a project that we've been working on for a number of years, where we take available map layers and put these map layers into a GIS. And we have fertilizer usage data by county. We have some manure estimates from the Ag Census that comes out every 5 years. There's another Ag Census due out in 2012. And we've been working with a company called PAC Interactive, PAQ Interactive, Quentin Rund is a person that we work with there. We have a great partnership with his company. He provides database expertise and GIS expertise, and we provide some of the agronomic expertise, and it's a good association. And what PAC Interactive has done is create a web-based tool for us, so that you can go to this web address. NUGIS is what we call it. This isn't to be confused with the rock guitar player that's also a hunter. But this is nugis.ipni.net, and that's a place that you can go and get these interactive maps. What I'm showing you here is a K2O balance. And you can look at this as a county level. You could look at this at a watershed level, if you'd like, a sub-watershed level. And there's also a neat mask that you can put on here that just looks at the tilled arable acres. So it shades things in according to where the crop's been grown. It's a very nice tool. Red here means negative budgets. Negative budgets means that we've had more crop removal than we've had nutrient additions. All right, so those are nutrients out of the system. And as you would expect for South Dakota, you've been mining the soil K because your soil test K levels are higher anyway. More arid conditions, higher K levels naturally, so it's okay to mine those. And you've been doing it for decades. However, as I'm sure you've been kind of following some of the work at South Dakota State, there are instances where we're seeing some potassium deficiency on the eastern side of the state where you've traditionally not seen potassium deficiency. And unfortunately in soybeans, it doesn't always occur according to the textbooks. If you're familiar with textbook descriptions of potassium deficiency, it occurs on the lower, older leaves first, marginal necrosis. However, what we're seeing in some of the soybean varieties is it occurs in the upper part of the plant during pod fill. And it looks more like a micronutrient deficiency, like manganese. So it's something to be aware of as you're out there scouting. And so this is it's an appropriate balance for South Dakota. However, just be mindful that this can only go on so long. So maybe just keep monitoring, keep looking at soil tests, make sure you're testing soils for potassium as well as phosphorus. It's usually part of the package, but just keep an eye on it. It's not a problem in many areas yet, but it can get out from under us if we don't watch it. Okay, to just give you some idea of what can happen, this is what we call, actually scientists aren't sure what to call this. We call it either soil test calibration data or soil test correlation data. It depends on who you're talking to. We have no standard terminology, unfortunately. But this shows what happens to yield if you don't fertilize the crop. And these are hundreds of site years of data from Iowa State University. It's the most recent data that we have and the largest data set that we have. And this is for both corn and soybean. And what you're looking at here is on these bottom axes, this is a soil test potassium level, ammonium acetate K, for both graphs. And soybean is on the right and corn is on the left. And the vertical axis here is relative yield. That's the percent of a fertilized plot that you're getting. So in other words, each of these points represents an unfertilized experiment and looking at how that compares to a fertilized treatment. And you can see that as you move to lower soil test K levels, you start to see decreases in yield. And the farther down you go on soil test potassium, the more yield you lose. Now what's interesting is when you look at this graph, you notice that it is messy. I mean, this is basically a cloud of points that kind of looks, it kind of has a shape like this as you follow the cursor, but there's a lot of uncertainty here. And that's part of what we're trying to manage in these fields, is the uncertainty in the probabilities of response that we get. So as we get to lower soil test K levels, just remember that the probability that there will be yield loss increases. And that's regardless of whether I'm talking about phosphorus or potassium. And I'll show you something exactly like this for phosphorus. Okay, just like I showed a K2O balance, this is a phosphate balance for the region. And here you can see that in South Dakota, we've actually had things that are yellow, which means that we're fairly balanced. We're applying about what we remove with crop harvest. And there's some areas that are actually a little bit green, which shows that we're actually a little bit positive. We're applying a little bit more phosphorus than the crop removes. What would you expect to happen to the soil test levels if you're applying a little bit more than you remove? Would they increase or decrease? They're going to go up a bit, right? So this whole idea is that, you may be building the fertility of these soils when you're exceeding crop removal. Okay, so just another graph just like we have for potassium. This one's showing the yield losses that you can get if you don't fertilize at various soil test levels. And you can see, I'll point out for soybean that as you move down to these Bray P1 levels that are below 20 is when you typically start to see some higher risks of yield levels or of yield losses, and those risks increase the lower that you get in soil tests. Now what you might observe here is that as you compare soybean and corn, there's more scatter in the soybean data. That means as I go to higher soil test levels, I can still find areas, this was Iowa data, I can still find areas where I'm getting some yield loss in soybeans. I don't know what that means. I really don't. All it means is that we may not have all this figured out for what the best levels are for soybean yet. And we may see some yield losses where we weren't expecting some when we're managing things for corn. So again, because soybean is grown with corn doesn't mean that everything that we know from corn applies to soybeans. Soybeans are a different crop with different nutritional requirements. And so I don't have anything definitive to say here, just that there may be some higher risks at higher soil test levels than we have previously thought for just looking at corn. So let's just kind of take a look at what happens when we start growing these higher yields. If you take a look at the South Dakota Brookings County average yield back like in the 90s and early 2000s, it was somewhere around 40 bushels. And you take a look at what the removal rates were for 40 bushels of beans, and you think, all right, well, phosphate, I was removing about 31 pounds of P2O5, but if I grow 100 bushels, I'm now going to be removing 77 pounds of P2O5 per acre. And as I go from 40 bushels at 56 pounds of K2O, 100 bushels, I'll be removing 140. So remember, we haven't been applying K to these soils. And if we start growing 100 bushel beans, we're going to be depleting those K supplies even faster. Again, it may not be a problem. Soil test levels may just be high enough. But the phosphorus we need to keep an eye on. Remember, for the most part, we're applying about what we remove. But if we start removing a lot more, those budgets could go negative. We're balanced right now for phosphate. Something we don't worry a lot about is the nitrogen removal. We just think, well, soybeans fix their own. I just want to point out this number because this may become important later in our discussions. Soybeans are removing at 100 bushels about 370 pounds of nitrogen. So just kind of remember that number. Hopefully I can remember it because I've got a slide coming up where I'll have to remember it. So 370. We got calcium magnesium removal and sulfur removal. All right, you can see the differences there. Okay, so as you go from 40 to 100, that's a 1.5 time increase just in yield, and you have a 1.5 time increase in nutrient removal. It's a linear type of relationship. At least that's what we approximate. It may not actually be linear, but that's the best information we have right now. Okay, so here's the challenge. Yes, sir, you have a question?
Seed only or the entire plant?
That's a good question. I talked about nutrient removal. That was with the soybean seed only, not the entire plant. Usually when we talk about the entire plant, we refer to that as uptake. So good question.
Hey, Scott, if you get a question, repeat it.
Dave said that when I get a question, I should repeat it. So, yes. Yes, that was a comment. Thank you. And Sharon made the comment that was a comment, not a question. All right. And thank you for that comment. All right. So, one of the things that we have book values for nutrient removal. It'll say, soybeans will remove 1.3 pounds of nitrogen per bushel. That's a book value. However, all of you know that these varieties are very different. Your management conditions are very different. Your soil fertility is very different. So one of the things that would be good if you're trying to get to this 100 bushel is to really start nailing down what these budgets look like locally. You know what you're applying. Manure's a little iffy. If you've got manure, you can get it tested. I think that's meaningful. I'm not sure there's a lot of scatter in those data when you get manure analyses done, but at least you've got some record of the nutrients in that manure. But we don't do that for our crops. We take these crops and we say, well, there go the soybean seeds right out the door, but I'm not really sure how much was in those. You can always take seed samples and get them analyzed at the lab, and get your own concentration data and start putting that in a spreadsheet. And I've just shown an example. This is one for corn. This is just an example of some of the things that you can keep track of. Just the year that you took the sample, the yield level associated with that sample, and just what you got back from the lab. Just put the values in. You can start creating a little database in an Excel sheet or whatever software you want to use. So just a little quick summary for this part of it. It's just, I think, nutrient budgets. Let's just make sure that when we get to these higher yields, that we're paying attention to crop removal and looking at those nutrient budgets. And then why not do some of this locally? Let's not rely on book values. Let's get our own values and see if we can nail down these things a little bit more accurately for our specific conditions. Okay, one of the things that comes up when you start looking at higher yielding soybeans is, are they going to fix enough nitrogen? And I tell you, the research has been all over on this. There is no certain answer on this. Luckily, there was a really comprehensive review paper that came out a few years ago that looked at a number of studies and tried to summarize all of this. It was a peer-reviewed publication done by Ken Kastman out of Nebraska. And I'm going to just show a couple of things from that paper to get us thinking. First of all, remember, and this goes back to the gentleman's questions back here about what are we talking about, that the total amount of nutrients that are taken up by the crop is called uptake. And we take a look at how much the plant takes up, and we can really nail this down to 3 various sources that the soybean is accessing these nutrients from. And this is for nitrogen. There's something that's already in the soil. We often think that soybeans contribute to the nitrogen in the soil, which they do, but not the nitrate. Soybeans are scavengers of nitrate. So if you have nitrate left over from a previous corn crop or a previous wheat crop, soybeans are going to take up that nitrate in the soil. All right? And the more nitrate that's there, the more they'll take up. So they will, nitrate coming from the soil is a source of nitrogen in the soybean plant. Another place, of course, is where we think of the biological fixation from nodulation. Typically, about 50 to 60% of the nitrogen in the soybean plant comes from the nodules, from the nitrogen fixed by the nodules. And then there's another part that we could do with soybeans as well, and that is we could add fertilizer, and that would be a third source of nitrogen for the soybeans. So that's really the 3 places it can get it. If you take a look at how these relationships look, here I'm on this bottom axis, this is my nitrogen rate. As I increase this nitrogen rate to very high levels, you can see that a greater proportion of the nitrogen in the soybean plant, this white area, comes from the fertilizer I apply. And the more fertilizer I apply, this blue area decreases. This is the amount of N fixed by the nodules. So the more fertilizer I apply, the less I get from the nodules. Okay? And the more fertilizer I apply, the less it relies on the nitrate that was present in the soil to begin with. Okay? So let's just take a look at this. How big are these impacts? Well, this is what this review paper did, is across all these studies, it started looking at these relationships. What happens when I apply nitrogen to the maximum amount of nitrogen that I can get through fixation? And what you notice is it's curvilinear, which I was not expecting. It goes down very quickly. So in other words, if I apply the first 100 pounds of nitrogen, my maximum N fixation drops from a maximum of 300 down to about 100. So applying 100 pounds of nitrogen cut my N fixation by 2/3. Okay? Now,
Pre-planted?
that's a good question. The question was, because I'm repeating question, the question was this pre-plant? And actually it's across a lot of different a lot of different placements and timings. But it's basically, it's going to be pre-plant. A lot of it was R3, at just the beginning pod formation. That's a pretty typical time to apply supplemental nitrogen to soybeans. It's just as soon as those pods begin to fill. And a lot of nitrogen here that was applied broadcast or banded at the surface, at our R3. And it basically surface applied nitrogen, right? And you think about where are the nodules on the soybean roots, right? They're closer to the surface typically, right? So you're applying nitrogen where the nodules are. Now what was interesting is when they were starting to look at all these studies, they did find a few studies where they deep banded nitrogen, 4 to 6 inches deep. What was interesting is they didn't follow along that curve. This kind of makes you scratch one's head. And so what the hypothesis here is, and again, this is a hypothesis. This would have to be tested. We don't know enough about this. But you have supplemental nitrogen there, but it's below where most of the nodules are located. So it doesn't seem to be interfering as much with the acquisition of nitrogen from the nodules because the nitrogen is located in a different spot. So we don't think about this, these are interesting thoughts that came out of this review of the scientific literature. So I'm just here to share those with you, maybe do some thinking. Nitrogen doesn't always have to be applied at the surface. 40 pounds is typically what people are kind of thinking about for supplemental nitrogen, about 40 pounds. But that could be applied as a band. Okay, well, if I'm going to subsurface band, can I do that at R3? Probably not. But I could do it at the beginning of the season. But how is it going to be around? How's my nitrogen going to be around by the time that I'm at R3? Well, maybe we can look at some controlled release nitrogen products. There's a lot around right now. So maybe a band early in the season with some sort of controlled release product. Who knows? It's something to try. So that's kind of where I'm going with this. These are just some thoughts. If you've got this, a place to play in the field that you want to try some things, this is one thing to try. Okay. Then the last thing I'm going to talk about is phosphorus placement. I need to leave Greg some time to talk about on-farm research because this is all going toward on-farm research. Soybean roots are very different than corn roots, as you know, if you've ever dug a plant. First thing that the soybean plant does early in the season is throw down a taproot. Now, it's not a big taproot like it is with alfalfa, or sugar beet, but it's a taproot nonetheless. And so the photosynthate early in the season is going toward elongating that taproot right in here. And it's right below the plant. Now, that's different than corn. Corn is a fibrous root system, and you'll see a lot of the activity in the corn plant up here early in the season. With soybean, it's below the plant down here. Remember, the best placement for starter applications with corn is to the side and below the seed, right? In here somewhere. For soybean, there's some pretty good data that indicate that it's right below the plant. And I'll show you that to you. Here's one example of, this is some Canadian work. It's hard to find this work on soybeans because we always think, well, you broadcast P&K for soybeans and forget about it. But this was a calcareous soil in Canada. And I want you to look at, this is yield response in percent. So percent yield response is what we're looking at. And we're looking at different rates of phosphorus across this axis. You can see that you got about a maximum response across all these things, somewhere between 50 and 75 pounds of phosphate per acre. This was a very low testing soil, by the way. But look at this, 1 inch below the seed, you got your maximum response. You move it off to the side 1 inch, and you've decreased your response. You put it with the seed, it's too high. It's too high. You've decreased the response even more, and then the broadcast was the poorest performer. So, is this just something that was, a one-time deal? Well, they actually did some phosphorus radio tracer studies, looking at radioactive phosphorus 32. There's not a lot of work done with phosphorus 32 because, unfortunately, a lot of people that did work with phosphorus 32 are no longer with us. So, it's not something that people like to work with every day. But let's take a look. Because you use a radioactive tracer, you can find out how much of that phosphorus you applied actually made it into the plant. So this is a 44-day-old soybean plant, and again, directly below the seed, you got a 63% recovery of that phosphorus. 1 inch to the side now drops to 54% recovery. And 2 inches to the side, 42% recovery. All right? Now, that's all when it was 1 inch below the seed. If you take it 2 inches below the seed, those recoveries don't approach 1 inch below. So this is just interesting stuff. It looks like phosphorus below the seed could be a good placement method. And it's not one that we typically use. So this is something to think about as well. Brazil's already thought about it. This is a typical planting unit in Brazil. I was there last July. And you know, this is basically, you've got a knife that's injecting fertilizer, and it's right in line with the planting unit. So it injects it right below the row. And there's just acre after acre after acre. This is one shed, and you know, this is one line of planters. So I'm halfway down the line, and then it's 3 deep. So you know, this is it was interesting to see, but I couldn't help but take pictures of this because I thought, well, Brazil's already got the placement method figured out. So here's something to consider when you're looking at corn soybean rotations, and you're looking at narrower rows. If you want to look at 15-inch rows, well, we can start doing some thinking. We've got RTK guidance systems now. So now more than ever, we can keep track of the banding that we've done this year, the year before that. We can map that. We can start creating networks of bands in the soil however we want them to look, which is pretty exciting. And we can create a structure, a subsurface structure of fertility that looks however you want it to look. So here's just one possibility. If you want to grow corn in 30-inch centers, you could apply some phosphate before you grow the corn and then plant the corn maybe 2 inches off that or over the top. Then you can come in the next year and offset that band before growing the soybeans. You can apply another band of phosphate the following year, and now you've got bands every 15 inches, and you put the soybeans right on top of those. I mean, who knows? It may not be practical because you can't go right over the corn rows, but there may be some way to configure these systems, and it's just there to get you thinking. The soybeans do best, it appears, when they're directly over a band of fertility, if that's how you're going to be doing your fertility. So just some thoughts, things to research. And that's really, I think, where I wanted to go with this talk, and hopefully I've left Greg Carlson some time to talk about some on-farm research. But those are just some ideas and maybe something to play with.
Bob?
You mentioned deep placement. What do you mean by deep placement?
Yeah, the question was, what do I mean by deep placement of, were you talking about nitrogen when I was talking about that? Yeah, I think the literature was a little bit unclear about that, but it's typically about 6 inches is about below the surface, somewhere in there. Yeah. Good question. Bad answer.
Thank you very much,
All right,
Scott.
thank you.